Welcome everyone, and thank you for attending today's Learning Center webinar, Crawl, Walk, Run, 3 Real-World Patient Matching Case Studies, sponsored by Verato. My name is Mike Milliard. I'm editor of Healthcare IT News, and I will act as your moderator today. We look forward to your questions and comments, which you can submit at any time by accessing the question box on your screen, and we'll make every effort to answer those questions during the presentation's live Q&A. Patient matching is at the forefront of the national health IT conversation. Senators are urging the GAO to consider a national patient matching strategy, and ONC and CHIME have both run patient matching competitions in search of a better approach. Our speakers for today's webinar are Mark Leroux, CEO of Verato, and Joaquim Neto, Vice President of Healthcare for Verato. During this webinar, they'll explain a next-generation matching approach called Referential Matching and discuss real-world successes that 3 large healthcare organizations have seen using that approach. So now, without further ado, I'll hand it over to Mark to begin the presentation.
Hi, thank you, Mike. Appreciate the introduction. And thanks, everybody, for being on this call, on this webinar for the early afternoon or late morning if you're on the West Coast. We appreciate your interest in this subject area, which is not just a subject area to many of us. It's our entire work life. It certainly is ours here at Verato. The webinar, as Mike introduced it, is indeed exactly what he said. We are here to describe 3 different tactics, 3 different strategies, if you will, towards getting a much higher, much better patient matching result. And as it's described here, crawl, walk, run. So a simple, easy step you can take toward this direction, a moderate step, and then a dramatic step. And which one you choose is entirely up to you and the situation in your enterprise. But the important note here is that there are multiple paths forward to much better patient matching. And Joaquim and I are not going to talk about it just in the abstract. We're actually going to go through real case studies, many of which that Joaquim has been personally involved in, so he has great depth of knowledge on these, both where the client or customer started and then what they've ended up with. But by way of a slightly expanded introduction, I'm Mark Leroux. I'm going to be your first speaker and the introductory speaker in this call, this webinar, and I am indeed the CEO of Verato. I'll introduce Verato in just a second. And with me, covering the latter half of this webinar, will be Joaquim Neto, and Joaquim is extremely well versed in this subject area, having worked in patient matching for almost 20 years now, so he's seen it go through many, many generations of technology and different implementation approaches. So what he's got to say will be really insightful, I believe, for everybody. But let's get to the material. Very quickly, Verato overview. We're a software company. In fact, we're a software as a service company, a SaaS company, offering patient matching as a service. And as Mike mentioned in his introduction, it's all about, with us, our innovation for the market is the maturation and the introduction of true referential matching as part of the patient matching problem space. So we're venture funded, located in Northern Virginia, and we've got an immense amount of investment already applied and inserted in our technology that we are now offering to a wide range of clients that you see, some of which listed here at the bottom of the page. These are all many of our healthcare clients. We have some clients in other industries as well, but healthcare is truly our specialty. Now, just to get this started, I did say already that this webinar is all about 3 different tactics to achieving much better patient matching. But to some extent, anybody's choice of tactic kind of depends upon where they are today. And so I thought I'd start this webinar off with just a simple framing slide, this one, that based upon our experience here at Verato describes the range of different patient matching states that our customers have been in. And very quickly, at the far left, some of our customers are entirely basing their patient matching strategies on using the built-in MPI, or the patient matching technology, embedded in their EHR system, or perhaps embedded within their HIE system. But it's part of a larger operation, this subcomponent that does patient matching. And indeed, it is a valid strategy to base all of your patient matching on that one vendor's technique, even if it's a suboptimal technique, because it's just part of a bigger suite. Many customers of ours have found that to be a little bit limiting, and they've gone to this next stage where they've done some homegrown patient matching. They've built a layer of integration typically on top of packaged software, maybe as part of their data warehouse or maybe as part of a simple but high volume patient matching operation that would supplement what's going on within their EHR system. Thirdly, we see customers of ours who have a mixed bag. They have both EHR-based matching going on in some situations in some hospital systems with some EHR vendors, but they also have separate MPIs, third-party MPIs or outboard MPIs operating either for specialized use cases or for specific hospital implementations. So that's kind of a mixed bag solution. And it's a heterogeneous solution. Obviously, it implies that there's not much patient matching that's going on across those different islands. And then on the far right, there's perhaps the most homogeneous solution. That's the solution whereby enterprise commits to an EMPI, an enterprise MPI that offers patient matching to all of the systems within the enterprise, the EHR systems, the HIE systems, and any other things going on. But all three of these things are valid starting points to discuss what could be done better. And in fact, before I discuss what can be done better, what I'd like to do is I'd like to go to the next slide, which is indeed a polling slide. So this gives you all an opportunity to get involved in this webinar, at least to some extent. I'd like to ask each of you to pick which of those four different stages or configurations best represents your enterprise. So click the button you have there. Click the button you see that best represents where you currently are, and in a few moments we'll see in aggregate where our audience is in its current state. So take a few moments. Okay, some results are starting to come in. I'll wait just another 15 seconds or so. I can see the results, but you can't. They're very interesting. Wow, look at that. You're going to be amazed. Okay, maybe not. We'll go to the next slide. In just a second, you can see the results. They're still coming in, so I just want to give it another 5 seconds. 10, 4, 3, 2, 1. Polling's over. Oh, it's still changing. Let me just push this slide so you can see where the results are right now. So for all of those people who are fast readers and quick decision makers, here's a snapshot of where people consider themselves today. And it's interesting, the top one there at 50% of the respondents would say that they base all of their patient matching solely within the patient matching technology embedded in their EMR or HIE software, which is quite interesting, but also pretty expected when you think that companies have spent $50 million or $100 million implementing major EMR systems. It makes sense to use their patient matching, at least until you've concluded that it's not supporting the needs well enough, and then you can start looking at other outboard solutions, which is probably what we've seen with the 14% in step 2 there. People have supplemented their EMRs with external patient matching capability, maybe for specialized use cases. 18% of the people said that they've got a mixed environment, some MPIs built in, some third-party MPIs for specific use cases. This is probably the most expedient solution. When you need to get something up and running quickly, you do it on a smaller scale basis. And indeed, it looks like 18%, so almost 1/5 of the people, respondents anyway, have committed to an enterprise-wide MPI deployment to be used by all of their systems, which is the right architectural approach generally if the technology is strong enough. Now let's talk about that technology. All of the solutions that you saw on the previous slide are undoubtedly based upon a technology called probabilistic matching, or a technique called probabilistic matching. It's the foundation for almost any MPI technology. And it's a well-formed discipline in computer science. It's just been applied to identity matching in the last 20 years. But the problem with patient matching and with this probabilistic matching technique is that it's entirely dependent upon the quality of the data that's being matched. And one of the sad truths is that upwards of 30% of all of the demographic data in anybody's master patient index, and I say that as a broad generalization, but it's true in healthcare and we've seen it true in other industries as well, at least 30%. 30% is a good, solid, conservative number. That data is either incorrect, it's incomplete, or it's out of date. So you've either got sparse data, incorrect or default entries, or you've got old addresses and old names. And this is just intrinsic with identity information. It does change over time. There are errors during the input. There are ambiguities between parents and children and twins and spouses. And indeed, rife within many of these systems is just simply incomplete. People put in 11111 for their Social Security numbers because they have privacy concerns. And the systems don't catch it. They just accept it and push it forward into the rest of the system. So all of these MPIs, everything we're dealing with today in healthcare and in other industries, we have to expect that a good proportion of our identity data is incorrect or out of date or incomplete. And that indeed is the challenge for the MPI technologies. And in fact, it's not just frozen at that point in time. The challenge, or the fact that the data is bad, the issue that the data is errored, intrinsically errored, is a challenge. But what is an even harder challenge in healthcare specifically, but in other industries as well, is that the number of systems that are contributing identities to this database, to this MPI, is growing, and it's growing quite rapidly. And an intrinsic truth, or an inherent truth in identity technology, is that the more data that flows into a centralized repository like an MPI, the more chance you have for an error. And as soon as you get one error for one identity, that identity then is poisoned for all future use. It will always have the possibility of getting an overlay or a duplicate because of one entrant that got applied to the correct identity, but it was carrying errors with it. And we're seeing this in healthcare. We're seeing many more systems connecting to the MPI, increasing the number of errors that are in there. And it's not just the number of systems, but it's the interactions between enterprises for medical records exchange or patient engagement, or the consolidation and merger between enterprises. The demands that we're placing on our MPIs is growing quite dramatically now. Everybody feels it, and everybody feels the inability of existing MPIs to accommodate this change rapidly and still maintain high quality. There's a strong tension there that's not healthy. It's not good either direction. And in fact, the stakeholders that now are aware that patient matching is a problem has grown. I mean, the CEO of a hospital system has always been somewhat aware that patient databases and patient matching is part of the entire ecosystem, but now many of the CEO's strategic initiatives are dependent upon the patient matching capability. Many of the CMIOs or the CIOs initiatives are also dependent upon patient matching, and the CTO and the HIM management team, they also have their own demands on patient matching. So a technology that perhaps snuck into the organization, not as the mainstream purchase or not as the marquee purchase or marquee product, is suddenly foundational to many important initiatives and many really important stakeholders. And in fact, this focus has not just within the four walls of an enterprise or a hospital system, but it's indeed now got national attention. I think Mike mentioned in his introduction that the College for Healthcare Information Management Executives, CHIME, hosted a competition, $1 million competition over a couple of years time frame, ultimately to say that there were no single technology in the range that they looked at that could solve the problem of a national patient ID. And specifically, they looked very specifically at biometric technologies and blockchain technologies as a possible answer. So I think we can conclude that those two technologies, at least so far, don't contain the answer to the problem. And similarly, healthcare, or the ONC, the Office of the National Coordinator, Healthcare IT Gov, also hosted a patient matching challenge. In fact, they looked specifically at algorithms, probabilistic algorithms, to see whether there have been any major improvements, any major changes in probabilistic algorithms that are going to tip the scales dominantly in the favor of better patient matching. And I think the conclusion of that study was that indeed probabilistic algorithms can perform quite well as long as the errors were very predictable and contained within a mainstream range, and they also allowed for a significant amount of manual effort and a significant amount of tuning of the algorithms. But that result, I think, belies the fundamental problem, and that is that only a certain percentage of errors lend themselves to probabilistic matching. And in fact, a couple more slides on this, just to paint the picture fully. The range of different types of data errors or data differences range from the very subtle, like twins or parent-child differences, where the identity data differs only very subtly between two people, to the other extreme, where the differences in the data identity are very radical. The same person gets married, changes his or her name, moves to a different address. Those are radical changes, but for the same person. But fortunately, many of the errors are in between those two. They're more of a mainstream kind of error, where it's a slight misspelling or a slight character transposition or a nickname usage. And it turns out that probabilistic matching kind of does quite well within that mainstream. And here are two examples. Here's the same person, Catherine Smith at 123 Main Street, is being compared to Cat Smith at 132 Main Street. So we've got a nickname and a character transposition on the number. Probabilistic matching will be able to find that match quite competently. And that's of comfort to all of us. I mean, perhaps 70% of all the matches, or maybe 80% of all the matches that are posed to our MPI fall within this relatively controlled and predictable mainstream. But the problems do occur when the changes are radical, and I think I've already mentioned this one, but I'll illustrate it with this slide. The radical changes we're talking about, the most radical that happens so frequently, is people get married, change their names, and indeed get married, change their names, and move at the same time. Here we've got Catherine Smith, who got married and became Cat Johnson, and she moved from 123 Main Street to 456 Elm Road. And what's even worse is that when she put in her identity information this second time on the right-hand side, she put in a default SSN, maybe because she didn't know if it was supposed to be her husband's SSN or hers or what. But regardless, a lot of the identity information between these two instances of Catherine Smith Johnson differ. And it's obvious to anybody who's in this business knows that no probabilistic matching system would ever declare that this is the same person, even though indeed she is. That's a problem. And the other problem occurs at the other end of the spectrum, where the differences between the two people are so subtle that you would think it's the same person, but indeed it's not. And I've already implied that it happens a lot with twins. It happens with parent-children. It also happens with very common names that all reside within the same apartment building, for instance. So Maria Garcia in a large apartment block in Houston, where there are a lot of Hispanic names. Or anywhere where there's a high density of people, any big city, New York, any big city, there's a high density of names. There are certain names that are very, very common, and it's very hard for MPI systems or EMPI probabilistic matching to pick them apart. In this example, we have Cat Smith, Catherine Smith, and Patricia Smith, Pat Smith, and indeed they're twins. So their names are quite similar because parents do that when they have twins. I know that by experience. I know a number of people with twins. They live at the same address. They have the same birth date because they are twins, and indeed their social security numbers are only 1 or 2 or 3 digits apart. Maybe just 1 digit apart because their parents submitted them for social security numbers at the same time, and the social security system spit them out sequentially. So no probabilistic matching system in the world would declare these two people to be different people, even though indeed they are twins and are different people. A probabilistic matching system would almost assuredly declare these to be the same person, but that would be an incorrect decision. So the question that we all struggle with as identity or patient matching professionals is there a technology that can do both the mainstream and these two extremes, the very subtle matches and the very radical matches? And we're really happy to tell you that that's really what Verado was built to do. That's what we're going to be talking about in this presentation. The cornerstone of Verado is a reference database. We've built it. We've curated billions of data records from the public domain, from publicly available sources, to create a large reference database of people's identities, curated from the credit system, the telephone systems, and aggregators of telephone information, and from legal and governmental records. We've applied tens of thousands of hours of data science to assemble that data in the proper way so that it is correct and referenceable, to the point now where we've got a database of over 300 million identities with upwards of 30 years of historical data, so it's not just a snapshot of their current identity, but it goes back over many years in time. And this database is not frozen in time itself, it's updated on a monthly basis. So it's a living, breathing reference database of really extensive identity information. And with that database, we're able to make matches. This referential matching that uses reference data can make matches that probabilistic systems just cannot. In fact, here's the example of Catherine Smith and Kat Johnson, the woman who got married, changed her name, and changed her address. This is one of those radical changes. This person, Catherine Johnson Smith, exists in the reference database not just as Catherine Smith, not just as Kat Johnson, but as one person who has both of those names validly applied to her, and both of those addresses, and her correct date of birth and her correct phone number, such that in this scenario, with referential matching, each of those identities would line up to the same reference identity because it would pick out of that reference identity the correct components. And so if the two sample identities map the same reference identity, then they indeed match each other. That's what referential, it's so easy to explain and to understand once you see it, that this is truly the power of referential matching. The other power of referential matching happens at the other end of the spectrum where the differences are subtle. In this case, we have the twins, Kat Smith and Pat Smith. And in the reference database, indeed, there are two people. There is a Kat Smith at 123 Main Street, and there is a Pat Smith, a Patricia Smith at 123 Main Street. And indeed, their Social Security numbers are written there with one digit apart. Because the reference database has two distinct people with exactly those profiles of information, even the very, very subtle matches like this one will be done correctly in a referential matching system because the reference database has the data from which to make the decision. It doesn't have to guess, it just has to look. And that's the important point. So just to summarize things, the conventional MPIs ultimately, we believe, are going to fail in the core mission that's being given to them and being expanded. It's going to fail because they're entirely dependent upon the quality of the data to handle the radical changes or to handle the subtle changes. And I've already said 30% of the demographic data is out of date or incorrect. Similarly, but not said yet in this webinar, is the fact that these algorithms, these probabilistic algorithms that we're talking about in traditional MPIs, they have a theoretical mathematical limit to their matching accuracy. They can't do magic. They can't detect twins if they have no knowledge of the twins' preexistence. They can't predict that somebody got married and changed their name because they have no knowledge of that. So there is a theoretical limit to how much the MPIs can do, and quite frankly, we've reached that theoretical limit. That is also one of the conclusions from the ONC study. And then finally, these existing MPIs, because they are so highly tuned and they require manual effort where their automatic efforts fail, they're difficult and expensive to maintain, but more importantly, they're difficult to expand to the expanding uses required of them. And then what Verato has brought to market, and this is my commercial slide here, is we have brought to market a next generation technology for doing patient identification, patient resolution. It's based upon big data, having built the reference database I've already talked about. It uses referential matching, which is a vast extension beyond probabilistic matching. It indeed kind of tests hypotheses using the entire database as its testing pool, as its environment or as its laboratory to do the testing, so that makes it more accurate, not requiring any tuning. And it's cloud-based, which makes it so that you don't have to deploy it. You can simply plug into it and begin using all of the data that's been pre-assembled by our data scientists. Bearing in mind that we are HIPAA certified and high trust certified with the highest levels of security to make sure that everything remains safe. So it's with this new technology that we're prepared to talk to you about how can I take advantage of this kind of advance in patient matching, either by doing it in a small way, small incremental way, crawl, or doing it in a more substantial way, walk, as referred to here as walk, or actually taking the full plunge and deploying the entire solution as a basis of patient matching. That's the run solution. So to illustrate those things in detail, and this is the true takeaway from this webinar, I'm going to introduce Joaquim Neto, our next speaker. Joaquin, go ahead and take it away.
All right, thanks, Mark. So let's just get into it. We'll walk through these three different ways that you can take advantage of the referential matching innovation, and we're trying to tie this back to the MPI life cycle poll at the beginning. So kind of regardless of where you're at in the life cycle, if you're part of the 50% of the participants who basically are using built-in EMR identification, or you've started down the path of homegrown or third-party MPIs, there's a few different ways that you can slot in this referential matching idea, really attack the problem, the underlying problem of the data issues that Mark described. There's a few different ways to go about that, so we'll just walk through three different use cases that take you to these approaches, and different types of organizations that have done those. So let's start with crawl. So kind of what's the simplest way to start down the path of referential matching and find out what it can do for you. So the reason we have a lot of clients that do this is one reason is because there's knowledge in the organization already that there's deficiencies in patient identity. So it's either ad hoc examples. There are issues come up related to duplicate records. Providers are running into duplicates. Physicians are running into duplicates as they're providing care. There's troubles with information exchange because of duplicate records. Things like that are kind of causing the issue to bubble up. But maybe you don't know exactly what the severity is, right? So it's an anecdotal thing. In that case, there's lots of organizations who sort of have a feeling that there's a problem, but don't know what the size of the problem is. So you might want to do a benchmark exercise, figure out where you're at. Maybe there's something that you have to do to improve the way you're dealing with patient identity. You're sure that's the case. You're committed to it, but you still need to quantify it in order to make an internal business case, something like that. Or maybe you need to get some analysis to figure out, okay, I know I have a problem, but what can I actually do to solve it? And so the idea is you can use this referential matching idea to kind of figure out where you're at. So what that looks like is basically you can take a snapshot of your MPI, whether it's internal to your EMR, your patient index, or a separate solution, and you can basically take a snapshot of that, and we can run it up against the reference database. So basically just the illustrations that Mark went through, and we can match all those records using the longitudinal demographic history that we have on file, and we can use that to find a fairly precise number of duplicates, and again, not limited by the quality of data that's inside of your one or more EMRs, but enhanced by the knowledge of the extra information that's in the reference system. So it's a pretty simple process. Take that snapshot, we run it through a process that analyzes it, determines the number of duplicates that are there, and then also provides some insight back into the data quality issues that are holding you back in your current state. So as we go on to the next steps, the walk and the crawl, there's a couple different ways that you can use our services to increase the accuracy. But with this crawl idea, we give you some immediate information on hand. So whether the fact that you have lots of missing, how big an impact the fact that you're missing SSNs on lots of records has. You get a feel for how often out-of-date data is actually causing you to not recognize that someone's the same across different facilities, things like that. So this is the first use case we wanted to talk through, is this crawl idea. And so this is just a quick story about actually an HIE, a smaller HIE, that had invested quite a bit of energy into a homegrown patient matching solution. They use that as part of a broader stack of technology to provide a variety of services. It was a fairly small population. They expected that they were doing a pretty good job. They didn't have sort of this lots of anecdotal evidence of issues, but kind of is the commitment to providing the highest quality services they could to their community. They wanted to do a benchmark, see where we're at. Let's find out if there's things we don't know. So we think we're doing a good job, but we really want to make sure. And so they went down this crawl approach and asked us to do a diagnose. So we processed their roughly 700,000 records, like I said, a fairly small data set, and found that there was actually 15% duplicate rate in there. So once we incorporated the extra data, the referential matching ideas, we were able to sort of see through. These were the hidden duplicates. These were the ones that are at that far end of the bell curve that Mark showed. So providing that knowledge, on the one hand, gave them an idea, a target for where they needed to get to, and then we didn't really cover this in this case study here, but the follow-on idea is once we found what those are, it became a fairly simple matter to say, okay, well, now that you have this knowledge, we can actually help you address those, resolve them, and in the end, the metric that they were really, concerned about was understanding the true number of unique patients they're covering, and that kind of represented the fidelity of their whole system. So after they got through with this exercise, basically did the cleanup based on this approach, the number of unique patients was affected by about 8%, which is fairly significant when you're thinking about duplicate rates. Okay, so this is sort of the step one, right? This is the crawl. This is maybe you're not sure exactly where you want to go, but you have a problem. You want to try to size the problem and start down the path of figuring out ways to address it. So let's talk about walking for a second. So in this case, you're a little bit further on. Maybe in addition to just having the instinct that there's an issue or wanting to benchmark yourself to make sure you're doing as well as you can, you may already be in a situation where you have a queue of work to do. So most organizations, providers always, most payer organizations, and increasingly large number of HIEs all have staff that work the ambiguous tasks. So going back to the bell curve illustration, your identity matching solution is probably automatically addressing all those things in the middle, these sort of standard small variations in data. But the things on the edges, those things end up in manual work queues typically. So these are the things that go to your HIM department, that go to your business analysts. And people have teams that work those things manually by investigating them, making the best decisions they can. And that's the typical process. So for many clients, this is kind of a measurement of how accurate your MPI is today. So if you have 100,000 tasks sitting in your backlog that have been generated by your MPI or by your EHR, these are potentially duplicate records. If you have 100,000 tasks and you have 1 million records, you have potentially 10% duplicate rate. And so folks put human resources against that. Well, you can take the referential matching idea and you can deploy it against that known set of potential issues, that tasks. And so a lot of folks will do that. They know they have this problem. They're attacking it the best they can with, usually limited resources. Invariably sticking on the provider side of the equation. HIM teams are doing lots of different things. They're not just managing duplicate records. Maybe they're doing coding. They're doing other quality things. And there's very often not enough time in the day to keep up with these new potential duplicate tasks that are occurring. And so you end up with this backlog. And like I said, it's often tens of thousands, many times hundreds of thousands, even millions of tasks that can accumulate in here. There's it's a natural fit for a technology solution to augment what is just not possible for people to take on their own. One of the other things that we see a lot with kind of what triggers us to get engaged with clients is individual events that drastically increase the backlog. So, with all the acquisition activity and partnership amongst different types of health organizations today, it's very common for there to be migrations of a practice moves off of the ClinicalWorks and into the centralized Epic system, for example, or two hospitals will merge, or there'll be an acquisition, and inevitably that results in a consolidation of EHR data. And whenever that happens, you get these huge spike in the number of tasks that are generated inside of your MPI or your EHR. And as you're in the middle of this process of bringing new staff into your organization, the last thing you want is for them to be faced with this kind of data quality nightmare of a bunch of duplicate records. So oftentimes that's kind of a precipitating event. You have this big spike in the backlog, and there's an urgent need to address that. And it's just not possible to do manually, and so the automated approach with reference data is really a natural fit. So getting on and trying to advance the slides here. Give me just a second. Oh, sorry about that. Quick pause there. So what does this actually look like, this idea of walking? So basically this referential matching approach that Mark outlined is available through a very simple API call. So it's a modern web service. You can call it directly from an EHR, from an interface engine, from an MPI. And we've done this quite a few times with a variety of different profiles of organization, different types of organization, payer, provider, HIE, different vendors of systems that we're integrating with, and have established a pretty good track record of being able to resolve 50 to 75% of these potential match queues. And again, that goes across different platforms. So whether you got one of the big EHR platforms, Epic Cerner, or one of the standalone MPIs, IBM Initiate, Mirth, a bunch of others, handful of others as well. You can do this approach, which is a fairly lightweight way to incorporate referential matching into your process. You don't need to throw out an existing MPI. You don't really need to re-architect the way your EMR works, because they all have the capability to resolve duplicates after they've been identified. So you can kind of walk into it and get a pretty big impact in a short period of time. So an example of this, we have a client, this is sort of a classic profile, an Epic client, had invested in Epic as their sole EMR. They have different facilities. They've got a process where they're bringing on additional organizations over time and, constantly migrating in to all use the same central Epic repository. But every time they do that, you have this uptick in the number of potential duplicates you have with these new data sources. So this is an example of an organization that already had some pretty good knowledge of their backlog. So they calculated that they had about a 20% duplicate rate, largely due to this acquisition and integration of new data. And they had some important go-live dates coming with new practices. And so that was the trigger to do this exercise of deploying our what we call Auto Steward, which allows you to bring the reference data in to resolve these potential duplicate issues you have. So we processed about 135,000 tasks that were sitting there, with just a handful of HIM people trying to get through those. And we're able to resolve just shy of 60% of those. All this happened in a pretty short period of time. It was 5 or 6 weeks for the whole project. And, to get through 135,000 tasks with a team of 4 or 5 people was going to take years. So it was a pretty good win, and like I said, a fairly lightweight exercise for them to do, and dramatically improve the duplicate rate. 20% is on the upper end of where you see when you benchmark organizations, and like I said, there's a perfectly valid explanation as you're integrating new data, but that's not where you want to be for very long. So we're able to bring that down pretty drastically. And then, as I mentioned, this is sort of similar to the crawl approach. There's a little bit of the aspects of each of these, kind of bleed over to different situations. We were able to do some analysis and kind of give them insight into the cause of, the cause of some of these duplicates. This particular organization was a little surprised when they realized they had this high duplicate rate because they thought they had a lot of Social Security data that was perceived to be kind of a silver bullet answer. But when you look deeper at that data, the quality just wasn't as high as it appeared to be. There were lots of these default values, one of the things that Mark mentioned before. So this was just an example of, as we were able to resolve these using reference data, provide some additional insight into why the existing solution was producing the results that it was. All right, so let's talk about running, doing the full solution. So the reason you look at doing something broader than those first two things is basically because you need an MPI. So we see two kind of profiles of this. So one is that you already have a standalone MPI, but the cost is prohibitive. So some organizations have invested a lot in on-premise technology, deployments, have teams built around those. There's a lot of hidden costs in that, not just the stewardship, which can be a huge expense, but also just the general maintenance. And part of this just has to go with the fact of dealing with software, and you need DBAs and network people and all kinds of things. There's a lot of hidden costs in upgrading software, especially with something like an MPI, which is fairly complicated, is oftentimes wired at the center of lots of processes. Anytime you need to go upgrade to new versions, those can be huge projects with lots of consultants, and there's not just cost, but there's distraction there. We also see organizations that can't get out of the cycle of tuning those on-premise traditional MPIs. So in the quest to get the accuracy up to where they want it to be, these configurable algorithms, you can kind of get into these never-ending tuning cycles, always trying to squeeze a little bit more accuracy out of it. Again, that costs money with consultants and so forth, takes a lot of energy, and it's really not going to get you there because the underlying issue is the data itself. So, another tweak to a weight on how you evaluate names is not going to get you there when the underlying data is just not accurate enough. So anyway, there's this class of folks that we see who have an MPI and aren't happy with it, want something better. Then there's another class, which is the other big chunk of organizations that are either using the built-in MPI to one or more EMRs or have done some homegrown things, and are just now recognizing that, due to the demands on patient identity, this, proliferation of data sources, the need to integrate more data, you're now at a point where you need to have an MPI that can handle multiple data sources. And so you're trying to integrate this multiple data, basically made the decision to get an MPI. And usually those are driven by some type of compelling event. So the solutions are needed, today. Maybe it's the rollout of a new pop health platform is coming, and that by definition requires integration of multiple data sources. There's a strategic objective to deploy that pop health solution, within a year, and MPI is going to be a dependency on there. So you need to have something that will produce accurate results quickly in order to support these other initiatives. So when it comes to Verado, how do you run? How do you deploy? Well, basically you're getting a SaaS solution. It's a SaaS MPI. So, like I said, you don't deal with software installation, all the ancillary IT roles you need to support on-premise software. You get all the benefits of SaaS, but you also have that backed by this referential matching approach that gives you out-of-the-box accuracy, which is key because the effort associated with kind of a traditional approach is oftentimes just as much about how you set it up and maintain it and run it, and there's a lot of expertise in there. Being able to deploy something, in the cloud that operates out of the box, it gives you a pretty huge advantage over that. Like the walk approach, the deployment of our universal MPI platform as an MPI, all the integration is via simple modern APIs. You can integrate that with a variety of different ways. In the end, you're basically just looking at a dramatically lower TCO, and for organizations that are spending lots of money on, other initiatives these days, that's an important factor. So example of running Rio Grande Valley is an organization in Texas, covers 9 counties. It's an HIE. They had deployed an all-in-one technology stack that had integration capabilities and portal capabilities and MPI capabilities. They determined that it just wasn't meeting their needs as far as being flexible enough for them to deploy the new kinds of services they wanted for their community, to handle new data sources. The solution itself, the matching, the MPI wasn't accurate enough. So they decided to re-platform. They had some very aggressive timelines. In the end, we ended up teaming up with an organization called ForCare to deliver the full solution, and we're able to implement the whole thing in 4 months. So that's basically integration technology, the portal technology, and the Verado Universal MPI, which is it's a short time for this type of implementation. I'm sure folks on the call today have all had experiences with similar types of deployments, and that really is something that doesn't happen that often. So that's a big that was a big factor in Rio Grande Valley success, was being able to get this whole thing deployed very quickly. In addition to the time savings, which they estimated, they did some analysis on their own and estimated that basically the implementation took about half the time that it would have if they'd implemented a traditional on-premise software type approach. And then they calculated savings versus the traditional software approach that they got with the Verado SaaS offering. There are thousands of duplicates extra prevented from using the reference data, and then for a small organization, substantial savings in operational costs year to year over a conventional MPI. So it was a nice full story that we don't have time to get into all today. We did actually just a month or two ago. The technical lead for Rio Grande Valley, Genaro Garza is his name, did a webinar and went into a lot of details on this. So that's something else to take a look at if you're interested in learning more about this and just what the experience of implementing a true SaaS MPI is like. It'd be a good reference point. So to kind of summarize it, the three things we discussed here was this: diagnose, benchmark, where are you at, and give you the data you need to start planning for improvements to your patient identity infrastructure and approach. Walking, if you have knowledge of the issues you have today, if you have any kind of backlog in your existing MPI or EHR, is a very lightweight way to come in and address those and sort of both see the benefits of the referential matching approach, but then also get a very quick win to deliver to your care providers. And then there's obviously the full solution that we offer, which is great for organizations that are just starting down the path of implementing MPI. Very quick and reliable way to implement, but it's also good for organizations that have invested a lot before and still aren't quite satisfied with the state of what they're getting out of the traditional solutions. There's ways to benefit from that too. So I know we went through fairly quickly those use cases. We have a variety of other different types of clients and profiles of things. So, of course, we're happy to talk to you more about some of those other use cases at other times. I think we have a few minutes for some questions. Turn it back over to the moderators.
All right. Yes, we do have some questions already, and we encourage you to add your own. We'll try to get to as many as we can in the 8 minutes or so that we have left, and I think we could probably follow up with you after the event if we don't get to them live. But first up, we have someone wondering, would there be an advantage to using a probabilistic approach as a first pass and then passing the remaining records through the referential matching process?
Sure, and that's a great question. That really is that's kind of probably a better way to describe the walk approach. It really is what we're doing with these clients, where they've already taken a shot at matching, right, with an existing MPI or EHR solution, and that has taken care of those 70% of the easy ones. The simple the simple issues that Mark described, and then it creates this queue for the remaining 30%. And you can absolutely feed that queue to us. That really is the way to think about the walk process. And if you already have that in place, then it's a great place to start. If you don't have that concept in place, you don't have a queue of the near misses. And some technologies are good at finding the near misses. Other incumbent MPIs are not as good at that. So it does make a difference what that is. But if you have it, then use it for sure. If you don't have that reliable list, if you don't know whether there are, hidden duplicates out there, then jumping straight to the run approach and just letting us find all the duplicates across the whole data set tends to be, more effective. But both are perfectly viable options.
Very good. Someone else has a question here. Biometrics would seem to be error-proof in terms of patient ID and matching. How did that prove to be inadequate?
Yeah, that's a great question. Mark, do you want to take that one, or do you want me to take the first pass of that?
Go ahead, Joaquin.
Thanks. I knew you were I thought we might have to fight over this one. So it's a great question. Biometrics is great. That's an emerging technology. We think that's going to help the patient identity problem in the long term. The way the question is phrased is right on. Biometrics, when it's deployed and used consistently, it is almost foolproof. And so it's great. The problem with biometrics is there are a number of different biometric solutions out there, and each one works differently. Each one codes the identity differently. There is not interoperability across biometrics. So you have fingerprints, you have iris scans, you have palm veins, you have all these different modalities, and then even within each modality you have different vendors providing those. So if you have an organization and you're a health system and you can deploy, homogeneously, comprehensively across every point of presentation the same biometric, and get adoption of them, with the patients, then it's absolutely valuable. But that's a big if. And what we're seeing is organizations that are adopting biometrics, it's helping where they're adopted, but you rarely get adoption across all the different points of entry. And then going back to kind of one of the initial pictures that Mark showed, just the number of data sources and the types of data that healthcare organizations are trying to integrate today. You get into population health, you get into, precision medicine. There's just this sort of inexorable movement towards getting more and more data, and it's not data that's all going to be captured, at the hospital registration desk. So that's where we think there's always going to be a need for resolution of the identity coming from data sources where there's not a single biometric at the point of registration.
Okay. Someone here is wondering, do we have to crawl and then walk and then run, or could we maybe take those, skip a step or take them in different order?
Yeah, right. And I probably didn't do it great job of explaining that. There definitely is this idea that you can progress through them, but you don't have to. You can start at any point. And if you looked at the clients that we work with today, you get a pretty even distribution of ones that come in at the crawl, come in at the walk, or start straight with the run. There is a pretty good mapping towards what your answer was in that first poll question, it ends up being pretty obvious once you look at sort of where the organization's at in the life cycle, where it makes the most sense to come in.
Someone else is asking, how do you calculate the TCO of something like this?
Oh yeah, great question. Yeah, for Rio Grande, we worked closely with that organization. We looked at and that's specifically those numbers I was showing there. Just to clarify, that was TCO as compared to implementing a traditional MPI. There's obviously value, sort of benefit for just resolving the patient identity as well. That's another useful way to calculate the value of implementing any patient identity solution. But basically, we looked at things like there's obviously software license costs, so whether that's a purchase license or a subscription, which it is for us. And then you have on-premise software. Do you need hardware? Do you need third-party software? What is the cost of implementation? Those types of things. How often do you need to do upgrades of that software? Once every couple of years, you're going to incur a $70,000, $100,000 project to do that. Those types of operational things, and then combined with the operational effort, the business operational effort. So with HIM staff, so you're going to need more HIM staff if you don't have the benefit of reference data helping you resolve more matches automatically, and so that ends up being part of the calculation. So we actually created a calculator that you could use, and I don't know if we have it it was not in this material, but I think we could probably provide the link to that. And you can actually punch in, here's the number of patients you have, here's the number of HIM staff you have, some things like that, and get a little feel for that TCO value. So I'll see if we can get that sent out as part of the follow-up note to the attendees.
Yeah, we'll include that one.
Great.
Cool. Squeeze one more in before we wrap up at the top of the hour. You said you integrate with Epic. Do you integrate with Cerner too?
Yep, for sure. Yep, we did the Epic case study here. We definitely have clients with Cerner and different varieties of Cerner and Millennium, Sorian, and then some other EHR and MPI vendors that I didn't have on that one slide. So we've gotten a pretty good track record for integrating with all the different EHRs and MPIs. So we've done a lot of them, and we feel good about being able to integrate even with ones we haven't seen yet, because we found some pretty common patterns for how we can slot in there.
All right. Well, thanks again to Joaquim and Mark for a really terrific presentation, and thanks to everyone who joined us today and submitted questions. We are out of time, but please be sure to complete the evaluation and share your thoughts with us before you log off. And so I'd just like to thank our speakers once again, and have a great day.
Thanks very much, Mike. Bye.